All right, remember our test is, or not a test, but our quiz is going to be on Thursday. All right. Now let's talk about it real quick. For those of you guys who are uh, moving ahead, just pay attention to the initial response here. All right. Your domain, right? That's just a list of the what? X values, correct? And the range is a list of the what?
Y.
The Y values. All right. So for question number one, I kind of would like it written like this. This is your domain is equal to. Now again, somebody asked me, do you have to put it in numerical order? I like it in numerical order. All right. So the domain would be 2 and 3. And again, remember, you don't have to repeat. You don't have to repeat. All right. Now range. All right. What? I'm listening.
Why can't this 3, 2, 2, 3?
Because you weren't listening. All right. The range. All right. The range is a list of the what? The Y values. All right. So again, the Y values 1, -5, 4, and 3. So write them in order: -5, comma 1, comma 3, comma 4. All right. So now you listen to me. I said the numbers are not repeated, and you put them in order. All right. Now for question number 3, same principle: domain, range. Your domain looks like it's what? Yes, 1 and 3. And your range looks like -4, -2, 0, 5. Anybody have any questions? Agreeing, it's simple. All right. Very important. Very important though. All right. Number 5. Again, domain, range. All right. Again, try to put them in order if you can. So -4, 0, 2, 3, 4. Your range. Wow, the range is nice. It's just what? -1. Hopefully you understand now. You don't list them all out. You know, just list it once. That's all you have to do. Okay. Now, listen, believe it or not, I used to not think identifying graphs is that important. But on all standardized tests, they always put a bunch of graphs and charts and tables. So we're going to try to spend more time this year doing that. And most of the time, believe it or not, it's a multiple choice format. All right. So your job is to try to figure out, you know, what graph would represent this situation. It says identify the graph that displays the speed of a baseball being pitched and then hit. All right. Now, if somebody pitches the ball, right, is the speed increasing or is it decreasing? Increasing. Now, does it start out moving?
Yes.
Does the baseball start out moving?
Yeah.
I would say no, it does not. No, I know. So listen to me. So again, this is why I'm glad we're going over it. And I need everybody just to let me try to explain. All right? Initially, the ball is doing nothing but sitting in your glove. So it has no velocity. Right? So as soon as you pitch it, this has, since it starts out with no velocity, then we can say, there's a good choice. Let's look at this. So when you throw the baseball, initial velocity, in my opinion, would be 0, right? But as soon as you pitch the ball, it has what then? It has velocity. So what we say is the initial velocity, right? Because of your arm motion, your arm motion is giving it what? An initial velocity. All right, and that's again kind of why I'm talking about this, because it's kind of confusing. And so I'm going to try to look at all of these and kind of eliminate options. All right, so if you throw a baseball and as soon as you hit the baseball, what's the velocity?
Zero.
It's zero. Very good, because it was going in one direction, right? It's kind of like when you throw something up and let it hit the ground. When you throw something up and it turns around, what's the velocity? It has to hit zero at some point. If it doesn't hit zero, then it's going to keep going what? It's going to keep going up. Does everybody agree with that? Right? So we know at some point, does everybody agree that we can now eliminate what? What two can we eliminate pretty safely? I would say we could eliminate what? I think we can eliminate C and D. Right? Now, again, this right here says there is an initial velocity. All right, there is an initial velocity. Let's say, for example, we said, I'm just giving some number here, 50 miles per hour. All right, does everybody see that? Like when you throw a baseball, to me, all right, I would think that that the baseball starts out at what? To me, I would say that the baseball starts out at what? Zero. Does everybody agree with that? But let me try to explain something to you. That was my logic. All right. But in reality, actually, Connor was correct. All right. That when you throw something, your motion of getting ready to throw the ball gives the baseball what? An initial velocity. Does everybody hear me on that? Now, at t equals 0, and this is what I'm doing down here, just so you can see what I'm getting at, and try to listen to me because this is super important. At t equals 0. To me, this, if you said B, you would be pretty good. All right? But does everybody understand what we're talking about? Initial velocity, right? When you're winding up to throw a ball, it doesn't have zero initial velocity. All right? Because it's going to go from what? 0 to, let's say you start at 50 miles per hour right off the bat. Everybody agree with that? All right. So it has an initial velocity. And what would you say is happening to the velocity when you throw a baseball? It's changing speeds, but generally it's getting what? It's getting faster, correct? Right? Then what happens here? Why is it straight down here? I need you to listen, guys, because you're missing it. It's exactly right. At that moment in time, it's exactly what? It's exactly 0. Right? It doesn't take this amount of time for it to get to 0. Does everybody agree with that? So when you swing the bat, the ball at some point does what? Believe it or not. Stops. Now that was hard for me to understand. Listen to what I'm telling you now. Until I realized that it's a change in direction. Try to listen to what I'm saying. When there is a change in direction, that means the velocity is changing from positive to negative, or from what? Negative to positive, depending on how you're looking at the ball. All right? So at this moment in time right here, the velocity is exactly 0. And then what happens to it? When you hit the baseball with a bat, it goes really what? It goes really fast, really quickly. All right? And it goes out, right? And then what happens to it? Yes. So what happens as it's coming down? What do we say about that? When the baseball decides to come down, it has to stop, right? But in this particular case, it's not stopped yet, but it's just doing what? It's slowing down. Does everybody agree with that? All right. So again, the best answer here is A. The best answer is A. If you picked B, I totally understand that. Hopefully I explained something to you. All right, yes.
How did A put it shows that it's going up and then goes down, so how is it going down and then coming back?
Well, it's not. Now listen, that you made a very good point. A very good point. So what we're doing here now is it's not a change. This right here, listen to what I'm saying, is not a change in direction. You with me? It's the fact that it's the fact that the speed of the ball is going what? Down. So you hit it and it goes out really fast, but now it's doing what? It's slowing down, but it hasn't reached its peak yet before it heads the other direction. All right, the velocity is not zero. All right. Now again, like I said, I many times I tell you to please listen. What I just said, there's a lot of really good information there. For those of you guys who are getting smarter, listen to what I'm telling you. All right, that's an important explanation, very important explanation of graphs and charts. And I'm telling you, on a lot of standardized tests, they put these kinds of things on. And if you're not careful, all right, you'll miss this part down here. And we'll talk about initial velocity a lot. We're going to talk about initial velocity a lot. All right, so with that, I'm glad we did 6. Let's take a look quickly at 7. All right, I want to talk specifically about these. All right, it says, identify the graph that displays the depth of water in a swimming pool after the drain is opened. Now, in my opinion, you should be able to look at this, right, and eliminate. I think that's one of the most important things that we can think about when we're doing these types of problems. All right, so identify the graph that displays the depth of the water in a swimming pool. So every once in a while you have to drain your pool, all right, to clean the sides or to remarcite or whatever you're doing to your pool. So you drain it out. You open up the drain, and now what is happening? Is the depth of your pool increasing or decreasing? So right off the bat, we know the depth is decreasing. So I can eliminate what?
A.
I can eliminate A. All right. Now, at any point, is the depth of your pool going to increase?
No.
Does everybody agree with that?
Yeah.
So I can now eliminate what?
C.
I can eliminate C. All right, I can eliminate C. Now, the question is, all right, does the depth remain the same?
No.
No. So look right here at D, because this is confusing to some kids. What is the depth doing in D? It's staying exactly the same, right? So it's definitely not D. So it has to be what?
B.
It has to be B. Now, honestly, I want someone to, does anybody know of a pool that is exactly the same depth in the whole pool? You know?
A lap pool?
Yeah, that's true. That would be good. All right, a lap pool is the same depth the whole way. All right? But most of the times everybody agree there's a shallow and then it goes deeper and stuff like that. So if you were, my only thing about B, and this is what I'm trying to tell you, a lot of times you read into things and then that will cause you maybe to switch an answer. So in my question here, they're saying the depth of the pool is always decreasing at the same rate. Would you agree that's true or not? No, I don't think so. Right? Because as the pool drains, right, does everybody agree it's going to drain quickly in the shallow end, but then when you get to the deep end, what? It takes a lot longer for the water to go out. All right? But again, that's just why I like to cross things out. All right, I like to do it by process of elimination, not just look at one and say that's the answer. And that's my recommendation to you when you're doing these charts and you're doing these tables, is to eliminate options. All right, I think that's easier. All right. Now, let's go to 9. All right. So on 9, here we go. it says the following table shows car sales at a local car dealership for the first 7 days of October. Draw a graph to show the car sales for the first 7 days of October. So what am I going to have to do? I'm going to have to go to the end of my page, right? Everybody's going to have to do this. Go to the end. Well, actually, you know what? I think you can go back. I think it might be easier. Sorry. I forgot you can do this. All right. Here, I can add a page. Add a page, right? Now, when you add a page, then I can change that page to graph paper. I think that would be perfect. Isn't that nice? All right. And then you can just kind of put it in the middle and shrink it down and see. All right. Now, the next thing I want to do for you on this is I want to show you that, do we have any negatives here? There are no negatives. All right. So when you make your graph, all right, when you make your graph, you don't need the negative side. All right. So if it were me, I would do something like this. All right. And now I have to go up to what? 12, right? So I have to count at least 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have to drop this down a couple more. All right. There we go. And now, this is the day down here, guys. I don't want you to get lazy, please. And I'm not going to ask you to do this much. And this is the sales. All right. And then we're just going to plot the points. All right. Now, day 1, you're at what? 3. Day 2, you're at 4. Day 3, you're at 6. Day 4, you're at 7. Day 5, you're at 9. Day 6, you're at 10. And day 7, you're at 12. So that's what we're looking at. So everybody can do that. I'm totally sure about that. All right. Now, to me, it looks like we're increasing 1 and then increasing what? Right. Then increasing 1, increasing 2, increasing 1, increasing 2. I'm assuming that may be what they want you to see, but to me, it's not really that important. So that was the graph. Let's look at 10. Use the data, all right, to predict the number of cars sold on day 8 and 9. So if we just continue the pattern, we'd say day 8 would be what?
13.
Day 8 would be 13. And day what? Thank you very much. Easy as that. And then you have to list them as an ordered pair. All right. So I'm just going to go ahead and do that just to make sure everybody's good. 1, 3, 2, 4, 3, 6, 4, 7, 5, 9, 6, 10, and 7, 12. All right, somebody tell me the independent and dependent. Does anybody remember? Independent was what? Independent was the day. Now remember, your Y depends on what? Your X. That's how I learned it. The Y depends on X. All right, whatever the X is, I can find Y. So Y is your dependent, so your dependent would be what? Your sales. All right? Make sure you guys got that now. It's not that hard. A few things to memorize here. All right, but that's not too bad.
So
I'm listening.
independent is the
X. Independent is always the X. And the dependent is the Y. All right? Now, indicate the answer choice that best completes the statement. What relation is a function? Remember, every function, right, does not have x values that are repeated. Does not have x values that are repeated. So the answer is what? Does everybody agree we're at B? Because on A, right, 3 is repeated. On C, -5 is repeated. And on D, -5 is repeated. Yes, now's the time.
How come they didn't put them in?
Because it's an opinion. That's what I try to tell you. It's an opinion. I grew up, my professor told me, put the numbers in order. That's standard. All right? So I'm not going to mark yours wrong if you don't put them in order. I'm just going to say you're not listening to me. That's all. It's like 2 plus 3 is the same as 3 plus 2. We're not arguing over that, right? It's true, all right? X plus 5, I don't want you to write as 5 plus X. It's not wrong. It's just that's not what we do, all right? But I'm not marking it wrong, all right? All right, let's go to 15. All right? Now, which relation is a function? Now, remember, for a relation to be a function, it's got to pass the vertical line test. So every time you draw a vertical line, it can only touch the graph at what? One spot. So that looks like the answer to me right there. Right? But I don't do that. I go to each one. Right? What's the problem with B? Yeah, it touches the dot, so that's out. C, I can draw a vertical line here. Right? There's 2, so that's out. And here, this one's kind of lightly done, but hopefully you can see the graph is this stairs, exactly. All right? So at this point right there, if I draw a vertical line, it'll touch it more than one spot. Do you agree with that? All right, so I'm happy. All right, let's continue on to 17. I almost feel like we have to do 16 with 17. All right? Is that correct? Well, we need to read 16 in order to do 17, right? All right, so let's do that. It says a soft drink bottle filling machine can fill 22 bottles per minute. The table shows the relationship between the number of minutes and the number of bottles. Now, would you say that just plotting those points is good enough, or can you connect the dots there? I think you can connect them. Why can we connect them? Because there's time in between each minute that there's bottles being filled, correct? Do you understand what I'm saying, right? So technically, probably 16A would throw some kids off, right? But does everybody understand what I'm saying? In between those times, like 1 minute and 30 seconds, are there bottles being produced at 1 minute and 30 seconds? Yes. So that's why we can cross out A, right? Now B is just wrong, right? And what's the difference between C and D?
It shows that it's going up in between.
Yeah, to me, they're just misgraphed, in my opinion, right? Those are a little off, right? Yeah, so it has to be what? Now, on that, what I'm trying to demonstrate now is that if you're not careful, you could easily make what? You could easily make D a choice if you're not careful. Is everybody with me? All right, so make sure you're real careful. All right, so the correct answer is C. Now, it says, use the soft drink bottle table to predict how many bottles will be filled after 7 minutes. Well, we don't need a table for that, right? If we're doing what? 22 bottles a minute, right? So it's just 22 times 7, and don't take out your calculator. Do not. We're practicing. 22 times 7 is 20 times 7, which is 140. And then 2 times 7 is 140 plus 14, 154. All right, practice using your mental math right now. That's what I'm saying. You don't listen. That's why you just say things. All right, that's the problem. All right. All right, now on these particular problems here. Now, look carefully. I want to make sure you see them now. These up here, that's what we're referring to. All right? Those are the functions. Make sure you see that. So when I ask you for f of 2, all right, this is mental math for you guys. F of 2. 2 times 2 minus 6. What's that? Negative 2. All right, now make sure you know for certain that you're plugging this into the f function. All right? On 21, you're plugging into the what? In 21, you're plugging into the what? You're into the g function. All right? Now, this one you got to be a little bit more careful on, but I still want to do the mental math. Everybody pay attention on the mental math. All right? I don't want you plugging negative 1 in. I want you to think about it. So if I plug negative 1 in, I get negative 1 minus 2. Now, what's negative 1 squared? 1. So what's 1 times 2? 2. So now I have negative 1 minus 2, which is what? Negative 1 minus 2. What is it? Yeah, and I'm trying to tell you right now, you have to be careful on that. Now, if you don't understand why it's negative 3, I can walk you through it. Is everybody okay with it being negative 3? All right, be careful. Be careful. All right. 23, f of 7 minus 9. So I have to find f of 7. So somebody tell me what f of 7 is.
It's 8.
8. Anybody have any arguments with that? Then after we find that it's 8, I have to now do what? Which is what? Negative 1, guys. That's good. Now's the time. You got to speak up. All right? All right. Continue on. Now it looks like we got a new set of functions. All right. Now 25 is the one that I didn't get an opportunity to talk on your homework about, so I want to make sure you understand me. That just means plug h plus 9 in for what? For x. Brilliant. Into the f function. So again, I'm just going to draw. This has to go in for x. Now what's going in for x? H plus 9. H plus 9 is going in for x. So here we go. So I want you to write it. F of h plus 9 equals 2 times h plus 9 minus 6. Is everybody with me on that? All right. So now when I distribute 2h plus 18 minus 6, right? Is everybody happy with that? And then what happens to plus 18 minus 6?
12.
Now's the time I want you to speak up if you're not sure how I did 25. Yes.
So you plugged in h plus 9 for
X.
x.
Perfect.
Oh, okay.
And I demonstrated that. All right. Look at it carefully. Make sure you're good. All right. Let's try 27. Determine the domain and range. What am I doing for the domain and what am I doing for the range?
X is the y.
Yes. Domain is the x, range is the y. So for 27, here we go. Again, we already had these problems, but I'm just reinforcing. Negative 2, negative 1, 3, and 4. Range would be what? Negative 2, 1, 3, 4. Everybody happy with that? All right, perfect. All right, 29. It says, the graph shows the number of home runs hit by Andrew Jones of the Atlanta Braves. Express the relation as a set of ordered pairs. All right, so ordered pairs, right? I see 1, 2, 3, 4, 5, 6. Kind of annoying. What? Funny? 2, 3, 4, 5. How many points were there? 6. All right. Now, to me, what's annoying here is that it's kind of hard to see exactly what it is, right? But do you agree you can't hit like a half a home run, right? Or so on here, you would just have to say in 2002, 3, 4, 5, 6, 7. And now you're just finding the number of home runs. So what do you think it would be in 2002? 35. Then what? And then what? 29. And then what? 51. And then what? And then 7. That's easy enough for me. Do I care if you thought it was 37 and I said it was 36? No, I don't care. All right? I don't care at all. All right? I'm not that way. All right? All right, let's go to 31. Oh, sorry. Then it said, I forgot one other thing. And then explain the domain and range. So here we go. Domain, come on, just stay with me. And what? Range. I'm totally fine with that. We've done domain and range 10 times now. I don't expect you to write them all. I don't want you wasting. I just want you to understand, the domain is the what? X values, and the range is the what? Y values. I'm perfectly fine with that. There's a lot of questions. All right? 31. It says here, I almost missed the directions, determine whether each relation is a function. Good practice. 31, yes or no? All I'm doing is I'm looking here. Do any of them repeat? In 31. 5 repeats, so the answer is what? So the answer is no, because 5 is repeated. All right, let's take a look at 33. Again, all I'm wanting you to do is 5, 4, -7, 0, 2, 3, -3. Anything? So then, yes, it's kind of weird the way you say it. Nothing repeats, so yes, it is. All right, but that's exactly what we say. All right, let's look at 35. Okay, now we're off the graph, which is good. All right, now we're just reviewing whether or not you remember how to solve the absolute values. So here we go. For question 35, if you remember solving absolute value, s minus 7 equals 12, s minus 7 equals what? -12. Remember, there were 2 solutions for absolute values. There were 2 solutions for absolute values. All right? So in this case, it would be s is equal to 19, and s is equal to what? -5. Yay. Yes, ma'am. I added 7 to both sides. Good.
Oh, I was thinking.
All right. You good now? Yes, you got it. Okay, let's take a look at 37. So I tried to confuse you on this by writing in a different order, but that's not for us. 2x plus 4 equals 6. 2x plus 4 equals -6. Now, in this time right now, we're practicing the mental math again. I would like everybody in here just say x equals. For this one, x equals what?
X equals 10. Oh, X equals 5 because there's
Go ahead. Just
1.
yes, x equals 1. Very good. All right, x equals 1. All right, subtracting 4 first, and then once we subtract 4, we get 2, then we divide by 2 to get 1. Now, obviously, if that's too hard for you, then write it all out. All right, write it all out. Just like on number 37, I'd want everybody here to just be able to tell me x equals what? -5. Beautiful. X equals -5. And be on your way. If you can't solve a 2-step equation, we're in a lot of trouble.
So once you get what, so when you minus the 4 minus the 6, once you get that, you divide by 2.
Is that how you get 1 and -5? Now, what I'm trying to teach you now, is if you're not getting that, now you ask me a question, right? You see what I'm saying, right?
Yeah,
kind of like the same with what she was saying. I want you to start trying to make some conclusions. So what did we do? Subtracted 4 and got what? 2. And the only way I can make a 1 is if you see what I'm trying to show you, right?
Oh, okay.
So I want you to come up with that. Because you're uncertain, There's only one way I can make 1 out of those numbers. You see what I'm trying to say? Right? So you're just working backwards again. All right? Now let's take a look at 39. Now the reason why I said be careful on this is because the absolute value, anytime I take the absolute value of a number, it must be what? Is it possible to take an absolute value and for it to be negative?
No.
No. So this case would be what?
No.
Yes, no solution. All right? There's no solution. Because no matter what you take the absolute value of, it's never going to be what? A negative. All right? Remember, absolute value is dealing with distance. Quickly.
So if we can't do the problem if it equals a negative, how can we do the two problems?
All right, so we went over this the last time, and if I'm not mistaken, if my memory serves me correct, you asked me the same question. All right, so obviously I didn't make it clear. All right, so if I take the absolute value of 6, what does that equal? If I take the absolute value of negative 6, what does that equal?
6.
So now listen to me, because here's what I want you to understand. What is inside the absolute value can be 6, or what's inside the absolute value can be what? Do you understand that now? Right? It's not that it's equal to a negative. It's that when I take the absolute value of it, it's going to be a positive. You hear me?
Oh, yeah.
Right? That's the important thing. All right? That is the absolute important thing. All right. I'm telling you, you're just laughing now. We're having a conference. Just to let you know that. Absolutely. We're having a conference. All right? You can explain that to your parents. All right? So here we go. On 41, if you recall, on 41, don't just say it's no solution because it's equal to a negative. What do I have to do? I have to isolate the radical first. So when I isolate the radical first, it's 1 minus x is equal to what? 3. Beautiful. All right. Now listen,